So we have seen that what is the experiment conducted by Mr. J.J. Thomson to discover the cathode rays, and cathode rays are producing from where? At cathode or at anode? Everybody? At cathode. So that is why the cathode is always what charge, everybody? Negative charge or positive charge? It is negative charge. So we can consider the cathode rays also. The cathode rays which is produced at the cathode is also having the charge of negative. So that is only we used to call it as electrons. So Mr. Thomson made three conclusions. The cathode rays made up of negatively charged particles. The cathode rays made up of negatively charged particles. That negatively charged particles only we used to call it as, what we used to call, guys? Speak loudly. That is call it as electrons. Am I right or wrong? All of you? Nobody answering. So next, the electrons have a definite mass and charge which are independent of gas of which is filled in the inside the discharge tube. So you can fill any kind of a gas inside the discharge tube. So irrespective of the gas, the electrons which are producing, that is what the cathode rays which are producing is always having the same amount of mass and as well as same amount of charge. So that is the second point. And third point which have been made, all the atoms of consist of these negatively charged particles. So that negatively charged particle, every atom, negatively charged particles is present in every atom. That is what we used to call it as. What we used to call, everyone? The negatively charged particles, which is called it as
Electrons.
electrons. So these are the three conclusions which is made by Mr. J.J. Thomson after his cathode ray experiment. So I hope you all understand. So now in our today's class, we are going to study a properties of electrons. So please all of you write. So whenever you're talking about cathode rays, immediately you have to talk about the particles of atom. What is the subatomic particles of atom? Cathode rays means you should speak about what, Laksha? Protons are. Cathode rays means you should talk about what, guys? Electron. Okay. And anode rays means you should talk about protons. So now the first point, properties of electrons. Please note it. Every class, these things we are having importance. Next class, next year, 10th class, physics will get this charge of electrons and all. So right, properties of electrons. Electrons are negatively charged. Electrons are negatively charged subatomic particles. The charge of one electron is the charge of one electron is 1.6 into 10 power minus 19 coulombs. So what is the unit of charge from this? Anybody can tell me? 10th class electricity also again it will come. What is the unit of charge? Unit of charge. Coulombs. So please write. Unit of charge. Adi positive charge or negative charge, no problem. Unit of charge is coulomb. The symbol is capital C. So please note it. Capital C, coulomb. So as it is negatively charged, so this is what? Minus 1.6 into 10 power minus 19 coulombs. Understand, everybody? If you no need to mention minus also, no issues. But as it is electrons means negatively charged, so I am writing minus 1.6 into 10 power minus 19 coulomb. Everybody clear, Amma? Please respond. Next, the mass of one electron, if you have taken, the mass of one electron, if you have been consider, it is approximately 9.1 into 10 power minus 31 kilogram or 9.1 into 10 power minus 28 grams. So very, very important. Many times for Small, this Olympiad exams and all, they'll ask this. Of course, when we have importance. Why we are not considering the mass of electron in calculating the molecular mass? You'll understand this. Okay. So the mass of one electron is how much times it is smaller? Everybody. We all knows that. What is the smallest particle or what is the smallest atom or what is the smallest element? Anybody who is having a less mass? Only one proton. I already taught you while teaching the last chapter. The atoms are the element which is having only one proton. Anybody? Having only one proton. Who is that element?
Hydrogen.
The element which is having only one proton. The element which has only one proton. Anybody? Which has only one
Hydrogen.
proton. Yes, only one proton. Means that is the reason the atomic mass of hydrogen and the molecular mass of hydrogen is both one only. Do you all remember, everybody? The one and only atom, the one and only element whose atomic number and atomic mass both are same. I have taught you. Is it right, guys? Please respond. So that is what hydrogen. So compared to one hydrogen, you all remember the mass of electron is 1 by 1840th, approximately it is 47 is the exact one, 57, so you can write it, no issues. So 1 by 1840th the mass of hydrogen atom. Mass of hydrogen atom means in the sense of the mass of one electron is approximately 1 by 1840 U. Understanding? U or also we can call it as a what? AMU, atomic mass unit. That is what you have to remember. So that much extremely smaller. So because of this reason, we are not considering the mass of electron while we are calculating the what? Atomic number or atomic mass? Atomic Atomic number or atomic mass? Please respond. Learn now. Atomic number we are considering, we are representing with a Z, Z. Atomic mass, atomic mass we are representing with a A. Learn. This chapter fully we are going to learn that. Already you are having an exam also, the similar questions came, but still I am saying it. So atomic number we are representing with the what, everybody? Z. Atomic mass we are representing with the A. So please remember. All of you understand, Amma? Everybody? Yes, please. The next point. Right. The electrons in an atom are the electrons in an atom are the electrons in an atom are present present outside the nucleus. Outside the nucleus. So they are called it as, so they are called extranuclear particles. Clear, everyone? Please respond. Yes? Now, next one. Can anybody tell me, last chapter we have studied 1 mole. 1 mole means how many particles? I want answer, I won't tell. You say means I only will say. 1 mole means how many particles? Alfin will say. Agalya, Alfin. 1 mole means how many particles, guys?
Oh God.
Huh? 1 mole means how many particles? If you don't know this, you can get out from the meeting. No issues. I don't want nonsense, people.
అలాగే అటువంటి
1 mole means how many particles, Ra?
6.022 into 10 to
Avogadro
the 23.
number. Avogadro numbers. Avogadro number is how much? Everybody, Gokul. 6.022 into 10 power 23 particles. So, if I take like this, 1 mole of electrons. So, if I take, for example, the charge on 1 mole of electrons, the 1 mole of electrons is called 1 Faraday. 12th class you will get in magnetism chapter, electricity chapter. There you will get Faraday's laws. But of course, the transportation of electricity is based upon the Faraday's only, Faraday's principles. So, if I take 1 mole of electrons, the total charge is present. Am I right or wrong? The total charge on the 1 mole of electrons, which we used to call it as 1 Faraday. Very, very important point. So, please remember that. All of you clear, everybody? So, the last point about these electrons is the nature of electrons. Suppose the electrons are coming from me or coming from you or coming from other XYZ. Whatever it is, their nature is same or different, everybody. The electrons are coming from different bodies, but what about their nature? Their nature is same or different, everybody? Yes, please. If you are not ready to answer, not ready to involve in the class, please leave from the class. I'm saying you, no objections, anybody's no problem at all. Alfin, I already told you many times. When I ask the question, you should say, if not, don't attend the class. Charge of 1 mole of electrons, you people don't know. Agalya, you don't know 1 mole of 1 mole means how many particles? Avogadro number theriyada. Tell me everybody, irrespective of a source, what is the nature of the electrons? All are same or different? Everybody. Already we have made conclusions made by
Same.
Thomson. What is the second point of Thomson? Everybody. What is the second point of Thomson? Yesterday, last class we studied conclusions derived by Thomson. What is the second point? Read everyone. What you have written? What you have written, you read. Nobody written, huh?
Sir,
Yes, read.
electrons have different mass and charge, which are independent of nature of gas filled in discharge tubes.
Yes. Only one girl is writing, remaining all dumb, simply sitting correct. I know, understand. Many people are cheating only. That is what. So, irrespective of the source, the nature of all the electrons is what? Same. That is what is the last point. Write it. The nature of all electrons. Coming Saturday, I am going to check all the classworks. Let me see what you people do. Otherwise, please don't attend the classes. I don't want. I am having sufficient people, no problem at all. I don't want nonsense people, those who are cheating parents and me. So write it. They have the same mass. They have the same mass irrespective of their sources and same charge also. So whatever the source of their electrons, all the electrons, they have the same charge and the same mass. So these are the properties of electrons. So if somebody will ask, define the electrons, you can say, so the charge of electron is this, and what is the mass of electron is this much. So irrespective of the source of the electron, their mass and charges remain same. So that is what you have to remember. So anybody having any doubt, you can ask me. So basically, why the mass of electron is not considered? Because it is extremely smaller. So that is the reason we will consider it is a negligible mass and a negative charge. So that is the most important point you have to remember. So the negligible mass, what is the mass of electron? Everybody, it is having a negligible mass. How much it is? Anybody? How much is the negligible mass? What is the mass of electron? What is the mass of electron, Ra?
9.1 into 10 power minus 31.
And what is the charge of electron? Everybody?
Negative.
Charge of electron.
Negative.
1.6 into 10 power minus 19 coulomb. It is negative, I know. How much it is, I am asking. I am not asking negative or positive. Negative, how much it is? 1.6 into 10 power minus 19 coulomb. Do it. So this is what is the properties of electrons. Anyone having doubt, you can ask me. Mr. Gokul, Mari, what is happening, Mari? Are you there? Nothing people doing, simply making. Finish it fastly.
Yes, sir.
Everybody learn all the things. I'll check coming Saturday, I'll check definitely classworks. I want to see everything. You cannot cheat like this many days. Agali, are you doing or not? What is happening? Alfin, you are also leave from the meeting, Alfin. No problem. No issues at all. Write it. Next, completed everybody. Electrons over. So after that, what is discovered? After electrons discovery, what is discovered, everybody? Discovery of protons and anode rays. So discovery of protons and anode rays, it is not found by the Mr. J.J. Thomson. So there is another scientist. So Mr. J.J. Thomson proved that existence of electrons. That is only he has been done. He has proved that atoms are not the smallest particle. So inside the atom, there is another particles which are more even smaller. That is what he has been called it as a electrons, negatively charged particles, which is called it as cathode rays. So now, after that, the charged particles, in addition to the electrons, there is another one. So as we all know, atoms are what? Atoms are neutral in charge, or they are having positive or negative charge. Everybody.
Neutral
Atoms
in
are
charge.
atoms are neutral in nature. Atoms are neutral in nature. Means if they are neutral in nature means Mr. J.J. Thomson found electrons are there. So when the atoms are neutral, when there is a equal amount of negative charge and there is a equal amount of positive charge, then only the atoms are neutral in nature. So then in 1886, 1886, a German scientist whose name is called it as a Eugen Goldstein. Eugen Goldstein, he has been thought about this and he has been done the experiment in not Mr. J.J. Thomson done the experiment in what tubes? Everybody. He has done an experiment in what tubes? Tube
Discharge.
name, discharge tubes. So he has done the experiment in Crookes tubes. So he has done the experiment in the Crookes tubes in which a beam of positive ions were created. A beam of positive ions were created, and that a beam of positive ions, a beam of positive ions is only called it as what we used to call, everybody? A positive ions is only we used to call it as, yes, please, protons. Understanding, everyone? So, the experiment which is conducted by Mr. Goldstein, that is what is again is production of anode rays. So, how he produced anode rays and what it is be. So, let us discuss now. So, before I have told you while I am teaching, cathode rays, can you tell me the color of the cathode rays? Anybody? I have already shown you also. What is the color of the cathode?
Greenish color.
Greenish.
Fluorescent.
So now let us see
Fluorescent.
experiment conducted by Mr. Goldstein. That is what discovery of anode rays. So if you have been seen here, the color of them is red fluorescence is produced. That is what anode rays color. What is the color of the red anode rays? Everybody? Yes, please.
Red. Red.
Red. Okay. Anode rays. Hasine and Princey also. If not ready to speak, you can leave. That is not issues. So anode rays. So let us see how it will be and what is the color it has been taken. That is all we are going to make it now. So if you all observe here, all of you. So this is the experimental setup basically done by Mr. Eugen Goldstein. So for this, he has been taken, and I will show you the videos also. You can see that. So we'll get one side if you are getting the greenish color. Basically, this is a greenish color coming means what is the glow we used to call it as? Greenish color means what we used to call? Everybody. It is cathode rays. Am I right or wrong? All of you. So now for conducting the anode rays experiment, that is what Goldstein, he has been made another kind of a circular tube, a circular plate like thing in the middle of the tube. That is what I am going to show you. That is a tube which we used to call it as a perforated cathode. So let us see that and I will explain you. So you all observe this one. experiment will go directly. Yeah.
Most working professionals will hate me for saying this, but Google Sheets is the worst tool to use.
So this already experiment we have already seen. Now I want to
or
show
bright light.
Yeah.
When an electric field is applied across the cathode ray tube, the cathode ray is attracted by the plate bearing positive charges. Therefore, a cathode ray must consist of negatively charged particles. We know these negatively charged particles as electrons.
Yes. So this is what is the experiment.
Producing a beam of positively charged particles on the back of the cathode. As the positively charged particles pass through the holes or the canals in the cathode, they are called canal rays.
Now, I want to explain this. So all of you observe. So this canal rays also we can call it. What is another name of canal rays? We used to say anode rays. So please remember that. Now, for this, the experimental setup made by him is this one. So let us go back to here. So I will show you this. All of you see. So this is the exact experimental setup made by Mr. Goldstein for producing the canal rays. So now if you all observe here, so for this what is happening? He is supplying, he has been taken a discharge tube having a perforated cathode. So perforated cathode to produce the anode rays. So what is that perforated cathode means? This is what? Have you noticed that circular disc in middle, everybody? All of you? Please respond, guys. So that is only call it as a perforated cathode. Means a cathode tube, a cathode plate who is having a small holes. That small holes only we used to call it as a perforated. That is the meaning of perforated cathode. So what is the use of this perforated cathode? It will produce the what rays? Everybody. It will produce the, please respond. It will produce the what rays? Anode rays. Understand? So now what will happen, you see, when the tube was connected to about a high voltage, what is the voltage? I already told you. How much voltage supply? How much supply voltage?
10,000.
10,000 volts. So 10,000 volt of current is supplied. So you can see a very dim and luminous rays were seen and extending from the holes of the perforated cathode. And that is what the color, you can notice it, everybody. Red color light will be forming on the opposite side of this one. That is what anode thing. That is only used to a red color glow, which we used to call it as, what is to call anode rays. So that experiment I'll show you, animated video. So here what will happen means, these rays were moving exactly opposite to the cathode rays. After striking this perforated cathode, the electrons, that is what, the electrons will coming back and they will form the green color coating in here. And opposite side, the protons alone, separation will take place. The protons alone will move and they will form and they will be shining into the red color light in the opposite side. So that is what we used to call it as a anode rays. So now here if you see that anode rays, as they are passing through the holes of this perforated cathode, we can call it as a canal rays. So anode rays also we can call it as a what, everybody? Canal rays.
Canal
So
ray.
as they are having a positive charge, as these particles are positive charge, that is why we used to call it them. What we used to call, all of you? We used to call them as a protons. That is what you have to remember. Now, let us see what is the exact mechanism which will take place here. If I show you the animation, you will understand. So let us make here. Yeah. Here they will speak about magnetism and all. That is all will not. 12th class again will get it. So by the time we'll study. Just we'll see that how the anode rays will produce and how the cathode rays. So what is the color of the cathode rays? Everybody? Cathode rays will produce what color? Greenish.
Green.
And anode rays will produce what color? Red
Red color.
fluorescence. That is you have to remember. Okay, everybody here? That is.
Hey guys, I hope you had fun learning about all the experiments which led us to discovery of the first subatomic particle, the electron. We learned that atom is made of negatively charged electrons. But does that mean that atom is negatively charged? Obviously no. We know that atom is in fact electrically neutral. So, to counterbalance the negative charge of electron, there must be something inside the atom which is positively charged. How do you think scientists would have found out? Well, E. Goldstein was the first person who found out these positively charged particles, which eventually led to discovery of protons. Now, since negatively charged particles were originating from the negative electrode, which is cathode, where do you think these positively charged particles will come from? Well, these positively charged particles will originate from the positive electrode, which is anode. Now, since these particles would originate from the anode, they must be visible behind the cathode. To see this clearly, Goldstein used a perforated cathode. Now, a perforated cathode is simply a cathode with holes in it. He modified the tube by adding another gas chamber and placing this perforated cathode in the middle of it. Now, when he turned on the power, he saw this beautiful pinkish glow which was coming from the anode and which was visible behind the cathode.
Do you understand now here who is the positive charge? Anybody tell me? Who is the positive charge, everybody? This is the positive charge. Do you all understand, all of you? Mr. Mari? This is the positive charge. Positive charge is always what node? Everyone?
Anode.
Anode. And
Anode.
this perforated cathode, this will be act like a whom now? This perforated cathode, which will be act like a whom? That is the cathode. Do you all understanding? Before the discharge tube, we are having a two circular disc. I hope you all remember. Before a cathode rays experiment, we are having a two circular disc. One is positive charge, another one is negative charge. Am I right or wrong? Everybody, do you remember or not? So this is anode and this is a cathode. Yes or no, ma? Now we are using here, instead of cathode and anode disc, we are using a perforated cathode. Perforated cathode means what? Which is having a small holes. That is what we used to call it as a perforated cathode. Now, when the current is passes and going and hitting this cathode, perforated cathode, this cathode will separate the electrons, and these electrons will be bouncing back. These electrons will be bouncing back and they will be forming the green color light. That is what we used to say, greenish glow produced in the anode side. And the protons alone, they will be started moving through these canals. Canals means what? Small holes. And we can notice the opposite side, we can notice the red fluorescence. Red fluorescence is produced in the opposite side. So this red fluorescence only we used to call it as a what? All of you? That red fluorescence only we used to call it as a what? How it is producing? By which rays?
Anode.
Anode ray.
Anode.
That is
Anode.
what?
Anode.
Positive charge. Agalya understand? Shivani? Positive charge. Kavya? That is what you have to remember. Everybody clear? Mari? So electrons will be bouncing back. Electrons will be bouncing back and they will be forming the green color coating, green color light in the anode side, and behind the perforated cathode tube will get the red fluorescence. That is what we used to say is anode rays. As they're passing through the holes, canals, we can also call them as what? As they're passing through the channels, they can also call it as what we can call, guys? Channel rays, or we can call it as canal rays. That is what you have to remember. I hope you all understand. Any doubt you can ask. Mr. Mukesh, clear? Padma, understanding? Sanjay, Prardhana, Prudvi? Yeah.
He saw that these rays were passing through the holes in the cathode. He compared this to a rays passing through the canals. And that's why he called these rays as canal rays. And
that canal also we can call it as a channels. So channel rays also we can.
Many scientists who named cathode rays because they were coming from the cathode. Similarly, they named these rays as anode rays. So now that we have found these new type of rays, which are anode rays, we need to find out whether their properties are same or different from the cathode rays. So even though scientists had an idea that these rays are made of positively charged particles, they still had to verify that. So to verify that, they passed these rays through two charged plates and found that these rays were attracted towards the negatively charged plate. That clearly
So
tells us
everybody, we all knows that oppositely charged particles will show attraction or repulsion. Everybody, oppositely
Attraction.
charged particles. Yes, please.
Attraction.
Attraction. So now they bought two particles, two charges. One is positive charge and another one is negative charge. So automatically inside, if there is a negative charge, they will attract towards the positive charge. Inside there is a positive charge, they will attract towards the negative charge. So now you all see that it is attracting towards the what charge? They're attracting towards the what charge? Everybody.
Negative charge.
Negative charge means in the sense of inside what charge it is there? Positive charge or negative charge? Everybody?
Positive.
Positive charge. That is what you have to remember. Understand, Niroshi, Kishore?
that these rays are made of positively charged particles.
Yes.
Now, since these anode rays are probably made of particles, let's see what happened when they placed the paddle wheel in their path. As expected, the paddle wheel started spinning, suggesting that these anode rays are made of particles which have mass and velocity. So now, if you remember from the previous video, that when we brought a magnet close to the cathode rays, they were bent downward because they were negatively charged. So what do you think will happen when you bring a magnet close to these positively charged?
So when you bring the magnet, it is bending. See, electrons means they will bend towards the magnet. Protons means they will bend. Positive charge means it will bend what? Everybody. Away from the magnet. So please remember that. But this experiment, you will get this magnetic property. I am not saying you now. As it is 12th class, you will get. So anyhow, you remember the magnetic effect. They will show away from the magnet. Protons means electrons. They will attract towards the magnet. That is what you have to remember. Clear, everybody? All of you?
Charged rays? Well, you are right. These rays will bend upward because the direction in which rays will deflect depends upon the nature of the charge. Now, if you notice carefully, you will see that the deflection in case of anode rays is way less than compared to the cathode rays. But why is that? Well, I want to remind you that we learned in our ball and wind example that the effect of a perpendicular force on a moving particle in a straight line is always less in case of heavier object than compared to the lighter object. So what does that tell us about anode rays?
Okay, this is all we'll discuss. I will teach you. That's not issues. I hope you all understand how that experiment is connected. Everybody, please respond, guys. All of you?
Sir.
Yes. So anybody having any doubt, you can ask me. And there is another more beautiful animated video. So regarding this, so just 59 seconds it will be. Just I want to show you how it will be like. You have to imagine also. But of course, we cannot supply 10,000 volts in our lab. So that's why we are never experiment also. So 10,000 volts is not like right.
The existence of positively charged massive particles, known as protons, came also from experiments with modified cathode ray tubes. The perforated cathode was placed in the middle, and a plain anode at one end of the tube. The tube was filled with hydrogen gas at very low pressure. When a high voltage was applied to the electrodes, electrons flowing from the cathode to the anode collided with hydrogen atoms, knocking off the electrons from them. The resulting positively charged nuclei of hydrogen, which are simply protons, were attracted towards the cathode, passed through the perforations, and were detected at the other end of the tube as so-called canal rays. In this way, the next fundamental elementary particle.
Okay, so nothing else, just I'm saying. So this is how the anode rays and cathode rays will produce. So if you all understand, Mari, anything down, Mari, Mr. Kishore, all of you clear? Everybody?
Yes, sir.
So that is what it is. So now, and how and why this cathode and anode rays are produced, that is what we are going to discuss. And What is the properties of anode rays? That is all we are going to make it. So meeting is going to end, join back and we'll continue. So if you all understand this, then you write it. So what is another name of anode rays, everybody? Another name of anode rays. Also we can call it as
Canal trace.
canal
Canal
rays.
race.
And we can say everybody
Channel
also
race.
called as channel rays. Write it. Next, keep reading. How and why the cathode and anode rays are produced? How and why the cathode and anode rays is produced? So basically this also will pass under the what? Low pressure or high pressure of gas? We all knows, everybody. Under the low pressure or high pressure? Everybody.
Low pressure.
Under the low pressure. Under the low pressure only gas